Hi, this is the 2019 exam paper predictions. I've done 3 more tests now, so there's a total of 8 papers there for experimental probability. I'm still using the same method, whereas you practice lots of paper 1 questions, and so that's how you get good at paper 1. For paper 3, just basically know everything because it's a very short unit test. And then the high level paper I'm focusing on because the standard level paper is usually just a reduction, just a shortening of the questions for the high level paper. Alright, so that being said, I have given in to the fact that most people are going to watch this video the night before. I'm going to cram, so I've done a cramming checklist. So I'll go through that at the end. Right now I'll just go through the actual analysis. Okay, so what I've done here is I've added these 3 new papers here, and I've done just an analysis of those 3 papers here, and then the average comes up over here. Because there's so many papers now, there's 8 of them, you'll see that in most circumstances the average doesn't change, even though this one does change a little bit. There has to be quite a significant change in this trend here in order for the overall average to change. So what we discovered, first of all, every now and then there's a little bit of a really weird anomaly, whereas some questions sort of get an over, seems to be an imbalance. There seems to be a drop off in the coloured complexes, which is a good thing. Don't know why I just did that, but that's a good thing because that's a lot of memorization. And what seemed to have increased a little bit seems to be the cell potential, so I've started to highlight that, which is a sort of a good thing as well, because and spectroscopy, which is sort of applying and analysing rather than just memorising, which is in my mind a good thing to show that you understand chemistry. And so apart from that, you can see that those are some slight changes. Apart from that, the general trends seem to be the same. And so the major things you need to focus on are the highlighted bits, and so I have done a summary checklist, which is right here based off these things here. So all the highlighted things, if you just focus on those, which is about half the stuff, you should be able to get a 7 hopefully. So the checklist, here we go. Number 1, as always, which is a foundation for some of these other calculations down here. Can I do mass, gas, volume stoichiometry? Sometimes with limiting reagents, possibly not really worrying about that one too much. The next one is they always seem to throw up an empirical formula and a relative atomic weight question around the place. There's a little tiny bit of electron configurations. There's always something around periodic trends with a special love for ionization energy, because it just is a bit cross-curricular and ties in a lot of concepts. This one appears a lot as well, intermolecular forces, often what state it's in or how the change of state occurs. Make sure you can do a range of Lewis structures, shapes and angles. That's another major concept in chemistry. This one here I've sort of tried to ignore. It's always there, but it's sort of covered so much in year 10 that I think it's fairly easy, but it's always there, so make sure you know it. And so the major aspect, the thing that you should be focusing on the most, is just doing one example calculation of these ones here. And so I've focused here on average bond enthalpies, because that again covers nature of science, and seems to be far more popular than the other ways to calculate enthalpies. Balancing redox half reactions seems to have made a slight increase. Always equilibrium constant or acid-base dissociation constants, they're kind of similar, especially if you're using Rice diagrams or something like that. This one just sort of, with the KAs, sort of shows that you're a high level. But if you're doing a standard level test, make sure you know the other ways to calculate, or at least know how to calculate pH. That seems to have made a slight increase. Order of reaction and rate expression just for high levels. Cell potentials, so how to work out what the voltage is, entropy and G, and a range of spectroscopy questions that seems to be a slight increase. And so that being said, so spend most of your time here doing practice calculations just to refresh your memory over the last 2 years. That probably is the main thing you need to focus on. I'm going to assume that you're not going to be too bad with a lot of these concepts. And then the very last thing that you really need to focus on is always huge amounts of organic chemistry. And they love doing SN1, SN2 and oxidation of alcohols. If you're high level, they'll throw nitrobenzene in quite often. Oxidation of alcohols is probably the most common. I memorize all aspects of that: color changes, reagents, how to write it, where to put little squiggly arrows. And SN1, SN2 is even more complicated and is very popular as well. So just focus on those two, and possibly the third if you're high level. Okay, so that's about all I have to say. If you like this video, just put a like. Please put comments below, pre or post, whether these have been good in the past or whether it was accurate for the coming test. I'll put links in the description to some other good revision videos, such as Richard Thornley's common mistakes. And that's it from me. Good luck.